Okay. So we're still on volumes of polyhedrons, only let's work backwards. Well, whenever you see that, basically what you want to always do is start out with the general formula. Okay? If you have the general formula, then it's really relatively easy to work backwards. What's the general formula for the volume of a sphere?
It is for a sphere over 3
cubed.
Okay.
4/3 pi r cubed. Notice that because we're dealing with volume, it almost has to be r cubed. If we were dealing with surface area, it would almost certainly have to be r squared, not r cubed. Okay? Well, normally you fill in the radius and you calculate the volume. But in problem number 1, they've given you the volume, so you fill it in and now solve for the radius. And I mean, that's from oh, and there's a pi here on the volume. Don't forget, there almost always is there. There's going to be a pi. There's a pi over there. In other words, all of these are going to have pi in the volume, which cancels out with the pi there. Now, relatively easy. You have r cubed equals 3/4 times this number, 47916. What's the cube root of that? Solve for r. In other words, once you get all the knowns filled in, then it's just solving an algebraic equation.
Okay.
Make sure, I don't want to work with all those big numbers, but let me make sure you know how to do this. R cubed is equal to 64. What's r equal to?
R is equal to, is that not 6?
Cube root of 64. You have your calculator in front of you?
Let me get it.
What you really want to do is do this. 64 raised to the 1/3 power in parentheses.
So that's 4?
Huh? 4 times 4 times 4 is 64. But in a lot of these problems, you're going to have to take cube root. So you definitely want to know how to do it on your calculator, including the problem that we were looking at. Only it's a much bigger number. In other words, whatever that number is, you want to take it to the 1/3 power to solve for r.
Okay.
Okay. I don't want to spend our whole session doing arithmetic, so I don't care if we come up with the answers. Apparently the answer is 33. I'm going to presume that if we can set them up properly, you can do the rest. So help me do number 2. What's the volume of the thing equal to?
Volume is 1/2 of 4/3 pi r cubed.
Good. They want to solve for the diameter, which means if we can solve for r, we'll just double it. Okay? Okay, so now what's the next step? Tell me what the next line I should write is.
You can fill it in for volume, what the volume is.
Okay, what is the volume?
6,174 pi millimeters.
Don't forget the pi. I don't care about the triple millimeters. The pi is what you don't want to forget. And it's particularly easy to forget when they stick it next to m's because it looks just like an m. It would be really easy to forget that pi. Okay, now if I do a little bit of simplification, I have that. Well, let's make sure, as long as you have your calculator, let's make sure you can come up with this. What is r going to be? So r cubed, pi's are going to cancel out away. R cubed is going to be 3/2 times 6174. Go ahead and get that number.
Okay, so to
take the cube root of that, raise that to the 1/3 power.
Okay.
What do you get for r?
It was. Wait, I'm confused. How did you do this?
Okay, let's start with this step right here. Did you see how I got to this step?
Yeah.
Okay. Now go ahead and multiply 3/2 times that. Come up with a number. What's that number?
9,261.
So 9,261 equals r cubed. So how do I solve for r?
You take 9,261 and find the cube root of that, and that equals r.
What is that? What's the cube root of 9,261?
21.
Okay, so 21 equals r, but they wanted d. What's d equal
to? 42.
Right. Okay. All of these problems are exactly the same. I don't think we're going to have time to do all of them, but you can see that what's the general formula? Let's get all of them set up. And then some of them I want to get into in a little more depth. What's the general formula for the volume of a right cylinder?
V equals capital B H.
And what's capital B? And what's capital B equal to?
The area of the base.
Pi r squared. That's what I want. Okay.
Okay. Yeah.
Because they've given us the height and they've given us the volume. So again, I'm going to come down to an equation where I have r squared equals something. I can solve for r, double it to get to the diameter. Okay. So knowing how to get the area of that base is going to be different for all of these figures. Sometimes it's the area of a circle. Sometimes it's the area of a rectangle. Sometimes it's the area of a hexagon. So you have to know not just that the volume is the area of the base times the height, but that the volume is what is the area of the base. In other words, this is really the general formula you need to start with, or at least at the second step you need to get there. Now, 4 is kind of interesting. 4, we're looking for volume. Do we have a formula for the volume of an ice cream cone?
No.
But we do have the volume of a cone, and we know the volume of a semisphere. Okay, so our total volume here, let's write the general equation. What's the volume of the cone?
Pi r squared plus pi r slant L, I guess.
Well, the volume of a cone is 1/3 the area of the base, pi r squared, times the height. So that's the volume of the cone. The lower part. What's the volume of the sphere?
1/2 of 3/4 pi r cubed.
4/3 pi r cubed. Okay, so there's my total volume. And what do they give us? I'm having a hard time reading this. X is the lateral? Why would they give you the lateral?
Yeah, it's just the side.
What's the 12? Is that that's the radius of the sphere? Oh, that's also the radius. Yeah, it's also the radius of the cone, right? They're the same radiuses. So I know what volume is. 2832 pi.
Oh, yeah.
I know what the radius is. 12. 12 squared times h plus 2/3 pi times 12 cubed. So notice in that equation, there's only one variable, h. But h would be the distance from that to that. It's not going to be this lateral distance. So I honestly think they made a mistake here. In other words, our volume for cones is not based on lateral measurements. It's not a lambda. It's based on vertical height. We can solve for this vertical height here.
Okay.
Now, can we then solve for that? Maybe. Let me draw the triangle out. So if I draw a triangle like this, representing the right half of that cone, looking at it from the side, they're saying they want x, and we've solved for h. We know what h is, and we know that that is 6. No, that's 12. Now, as long as we have a number on h, we're going to be able to solve for x. So perhaps they did want you to solve for x. But notice you can't solve for x until you solve for h. You see what this triangle I've drawn down here represents? It represents if you were looking at this ice cream cone from the side, and just looking at this part of it, it would look like a triangle, with the vertical part being h, the height of the cone, and we solve for that, so we have a number on that. Well, we know the radius of the cone is 12, so if I give you the two short sides of a right triangle, you can solve for the hypotenuse using the Pythagorean theorem. I'm always troubled that they make you use such giant numbers here. Does that actually facilitate the learning of it or make it more difficult? In my mind, it makes it more difficult. These problems don't need to be using numbers like 2,832. They could use small single-digit numbers and teach you exactly the same thing. The only difference when they use a number like this is it means you're going to have to get your calculator out to get an answer. All right, 5's a little unusual. What's the general formula for this thing? What would it be if it was not missing that piece?
Hemisphere?
What's the formula for a hemisphere? Volume of it?
1/2 3/4 pi r cubed.
Always 4/3. Never 3/4. Okay, the volume of a sphere is 4/3 pi r cubed. So the volume of a hemisphere is half of that.
Okay.
Okay. Now, we don't have a full hemisphere here. What part of a hemisphere do we have?
Most of one.
What fraction would it be?
We have 360.
Right. 360 is the full circle. We're only missing 72 of it. So if I subtract 360 minus 72, I get 288. So that right there represents the fraction that thing is of a full hemisphere. Well, here's the volume of the full hemisphere. There's the fractional part that we have. So filling in for volume, 1800 pi. I've only got one variable, r. I can figure it out. Okay. Again, they ask for x, which is the diameter. So once you figure out r, you're going to have to double it again. Another unnecessary complication that merely makes it harder to get the answer right. In other words, they keep giving you one extra chance to make a mistake. Number 6. They gave us the apothem. What's the volume of that polyhedron? This time it's okay to use base times height.
52 times.
Well, when I say volume, what's the general? Okay, it's base times height, right?
Yeah.
What's the area of the base? What's the area of a regular polyhedron, regular polygon?
ASN.
It's 1/2 ASN, right?
What makes it 1/2?
Times the height. Okay. Well, they're giving us volume, so I can put that in there. And this time they didn't put a pi on the end of it. It's 0.6. Okay, and they gave us A. Go ahead.
Why do we use 1/2 ASN, not just ASN?
Hold on, let me open my geometry book. I might be misremembering that. Just a second. Is it just ASN? Areas of polygons. I can't find it. Area, no, it must be back here. Area of a polygon. Where's the formula for it? Area of an equilateral triangle. The area of a polygon is 1/2 ASN. Okay? So it is 1/2 ASN.
All right.
Okay? And I'm going to substitute A. They give us A of 33.2. Oh, wonderful. More big numbers with decimals this time. How many sides do we have?
We have 8.
Boy, you got me. From their drawing, looks 7 to me. I see 1, 2, 3.
Yeah.
And then I see 1, 2, and back. That's 5. And then I've got that side and that side. So I think it might be 7. So
okay.
N is 7. You know what? Let's back up a second. There's two formulas for the area of the base, and that's why they drew this picture screwy. It's 1/2 ASN, but that S times N is also the perimeter, so it's also 1/2 A times P. Okay? And by using that formula instead, makes this problem a whole lot easier. We don't need to know the shape of that thing. We don't need to know if that's a hexagon or a septagon or an octagon, because the area of the base is 1/2. I do know the apothem is 33.2, and the rest of it is the perimeter, and that's what they're asking for. So they don't really ask for the side length or the number of sides. Since they're asking for the perimeter, we don't care. In other words, I don't need to know how many sides there are or the side length if I use this formula over here. So it's a good one to know, because I've seen other problems like this where they're asking for the perimeter and they draw it in such a way that it's very difficult to figure out what the base surface is even. A trapezoidal prism. How am I going to find the volume of that?
Well, it's just base times height, right?
All prisms, right? Question is what is the base? In other words, the volume of all prisms is the base times the height. But remember, it's only a prism if you have two bases that are equal, opposite, and parallel. Which face that we're looking at there is the base? Is it the one, it's sitting on? It's not the one it's sitting on, because that's a bigger rectangle than the top one. So that's not what makes it a prism. It's not this face here. That's not parallel with its opposite face. So that's not what makes it a prism. It's a prism because this face right here is equal, opposite, and parallel to that back face. Therefore, it's the area of the trapezoidal face. Well, the area of a trapezoid is 1/2 base 1 plus base 2 times the height of this trapezoid. So this h over here is not the same h. What is that h right there? Which measurement on number 7 does that h represent?
29.
Correct. In other words, this h is the thickness of the prism. It's how much distance there is between the opposite and equal bases. So that h is 29. This h here is what? Looking at that right there.
10.
10, exactly. So I know I meant. So here's what I'll finish this up real quick here. So we end up with the volume being equal to the area of this base, which is the area of a trapezoid, which is this, times 29, the thickness of the prism. Okay? Now, that's the volume. They've given us the volume. It's 5,220. So what are we missing? We have base 1. We have h. Base 2 is x. That's the small base. So now we have 5,220 equals 1/2 times base 1, which is 22, plus base 2, which is x, times the height, which is 10, times the thickness of the prism, which is 29.
Okay.
That's why you always want to start with the general formula and work your way down. Notice that in that bottom equation, there is only one unknown, x. Everything else is a number, which means we'll be able to solve for it. It might be a little tedious algebra, but that's the whole point of all these problems, is to set up a general formula, plug in all the variables except one, and solve for that one variable using algebra. And that's the way to do all of them. Okay, but in all of them, you have to know a lot of formulas. In other words, you need to memorize, unless on the test, do they give you these formulas? Or do they let you use a cheat sheet?
I'm not sure. We will tomorrow.
Well, if they don't, have yourself a page of formulas, make up some flashcards or something, because you can't really even get started on these unless you know all these general formulas.
All right.
Okay? Including that one that's 1/2 a, not just Sn, but 1/2 a times the perimeter, which is more useful for this problem. All right. That's good stuff. Hard stuff, but good stuff. Mark, I will talk to you next Tuesday. Good luck on your test tomorrow.
All right. Thank you, David.